For this lesson, we are going to talk about radian measure. We want you to be able to know the definition of a radian and also to be able to convert between degrees and radians. Okay? Now, remember our unit circle. Our unit circle was based on a circle that had a radius of 1. Now suppose we still have that radius of 1, okay? And suppose we stretch that radius, try to measure how long that radius of 1 is bent around that circle. If we do that, we come up with an arc where all the lengths of that arc, including the length from 0 on up to however long that one segment wraps around, is 1, okay? And that is what we call 1 radian, okay? And it turns out, because of how things work with circles and pi and everything like that, that there are 2 pi radians in a circle. Okay? So, definition for a radian is, 1 radian is the measure of the central angle of a circle that intercepts an arc that's equal in length to the radius of the circle. So, we take that radius and we bend it around the arc of the circle, and whatever the measure of this interior angle is, whatever the measure of this angle is, once we do that, once we bend that segment of length 1 around that circle, that is the measure of 1 radian. Okay? So, there are 2 dimensions to measure radians in. We are able to measure radians, you know how we measure on the coordinate plane with x and y. Because it's 2 dimensions, we need 2 dimensions to measure. Okay? So with radians, what we do is we measure given a radius and then an associated angle. Okay? And that angle is in radians. So when we give a point, when we locate a point in radians, we give it as r for radius, comma theta for angle. So r is radius and theta is our angle. And there are 2 pi radians in 360 degrees. Now, that's nice, but it's not an even number. That's because pi is 3.14, so we have about 6.28 radians in one circle, okay? Now, it's kind of weird, and I know that, but if we deal with them solely in terms of how many pi radians there are, then the numbers are actually fairly easy to deal with. So let's convert between degrees and radians. When we want to convert from degrees to radians, we're going to actually multiply by pi radians over 180 degrees. Because if there's 2 pi radians in 360, there's 1 pi radians in 180. And it's just a smaller number, a smaller conversion factor than 2 pi over 360, and it makes it easier to deal with. So, we take our degree measurement and we multiply it by pi, just a multiplication sign, over 180. And all it means is we have to reduce 350 over 180, and that reduces down to 35 pi over 18. And this is where having a calculator that will do fractions and reduce fractions for you will come in a little bit handier for some of these weird degree measurements. Let's try another example, even though it's not written down here. Let's try something a little bit less complex. Say we want pi over 6. Sorry, giving you the wrong thing. Say we want 120 degrees. Again, we would multiply by pi over 180, reduce 120 over 180, and we're left with 2/3 pi, or 2 pi over 3. Okay? So some of these are not too bad. And you'll get much more practice in class with this. Let's learn now how to convert from degrees to radians. Now, For this, we multiply our radians by 180 over pi. Okay? Notice what happens here. When we were converting to radians, our degrees went on the bottom. When we're converting to degrees, our degrees go on the top. So whatever we want to convert to is what ends up being on the top of that fraction. So you only need to remember that those pi and 180 are equivalent. So pi radians and 180 degrees are equivalent. And then whatever you want to convert to is on top of that fraction. So if I'm converting to degrees and I'm given pi over 4 radians, okay, then I multiply by 180 degrees over pi radians. And our units cancel out, our pi's cancel out, and I'm just left with 180 divided by 4, which is 45 degrees. Okay, so let's do a couple other example problems here. Okay. Say we want to convert to degrees, and we have, oh, and I just noticed this was backwards here. It should be we're converting 2 degrees. I had a typo there. So we want to convert 2 degrees, okay? So if we want to convert 2 degrees, we're going to have degrees on top of our conversion factor. And I want to convert pi over 5 radians, okay? So if I do that, I multiply by 180 degrees. My pi's cancel out, my radians cancel out, and I'm left with 180 divided by 5, which is 36 degrees. Say I want to find 5 pi over 4 radians. And I want to convert that to degrees. Again, degrees goes on top, pi radians goes on the bottom. My pi's and my radians cancel out, and I take 180 times 5, and divide that by 4, and I get 225 degrees. Okay, let's try a couple more. Here I want to convert to radians. I want to convert 135 degrees to radians. Because I want to convert to radians, my pi radians will go on top, and my 180 degrees will go on bottom. So 135 over 180 converts to 3 pi over 4, 3/4 pi radians. Say I want to do, let's see, 7 pi over 4. No, I'm getting it backwards here. Say I want to do 330 degrees, and I want to convert that to radians. Again, radians is going to go on top. Degrees will go on the bottom. 330 over 180 converts to 11 pi over 6 radians. Okay? So I hope that helps you get an idea of the types of answers that you'll get for radians. 11 pi over 6, that's just 1/6 pi short of 2 pi radians, because 12 pi over 6 would be 2 pi radians. So that makes sense then to give you kind of a sense of where those numbers lie with regard to radians and degrees. And we're going to go back to your unit circle that we did for lesson 2 or 3 and add those degrees to radian conversions so that you can get an idea of where each of those is along that unit circle. So we will get lots of practice with this because I want you to be able to actually start to memorize a few of these, because you'll start to see patterns with the radians and how many radians are in each of the common degree measurements. Okay, we'll see you later.